Hello, Advanced Algebra 2 students. It's Coach DePaulo back with another video for Unit 6. This is Lesson 6.4. And you can first start off and do me a favor and go up to the top left-hand corner and you can take off that H for honors. I did make some changes from last year, but that wasn't one that I remembered. So, and then write the word advanced up there for me. And do the same thing to your assignment. All right, so these notes are kind of long, but I'm going to shorten things up a little bit as far as the video goes. When we get to page 3, I'm going to go pretty quickly. So what I'm going to need you to do is I need you to pause the video, and I need you to copy this portion of the notes on this back page. And what I need you to copy is not necessarily this stuff up at the top. I will talk about that. But what I need you to do is I need you to go and put this below each graph that's on that third page. And when you get to the bottom, you're going to have to go out to the side for part of it. Again, I'd like you to pause the video and do that for each of those graphs. I'll give you time to do the names when we actually get to that page. Okay, so I'm going to go ahead and I want you to pause right here and then come back in just a minute and then we can continue with the video. So what is lesson 6.4 about? Well, it's pretty much about this type of information right here. Let me scroll on down to this one. And here's what you're going to be able to do. By the time this video is over, you're going to not only know what degree means, but you'll know what the degree of this graph is. And you'll know what terms are, which I think those are pretty self-evident, but we'll talk about them anyway. You're going to know how many x-intercepts an equation could have. And not only there's going to be how many it could possibly have, and then it's obvious to look at the graph and tell how many a particular graph has. And then you're going to also know what ending behavior means and what does this right here mean, and we'll talk about that as well. Okay, so that's pretty much the notes today. So we do have a few vocabulary words that we need to get out of the way, and those will happen right here on this first page. And let's go ahead and get started. Okay, so today we're going to concentrate on this polygon right here. So if you would take and maybe write it right over here a little bit bigger so that we can see it a little bit easier. Plus, when I scroll down here in a minute, you'll still be able to see it. Okay, so this particular polygon has 4 terms, and I have harped on that all year long. What makes a term? And so something separated by plus signs and minus signs make things terms. So this right here is 1 term. This right here is 2 terms. This is 3 terms, and then of course this is 4 terms. Now, this one is just called a polynomial. We don't have a special name for a polygon or a polynomial with 4 terms or more. But for 1 terms, 2 terms, and 3 terms, we do. So for a 1 term, we call it a monomial. 2 terms, we call it a binomial. And 3 terms, we call a trinomial. Now, not only is this 4-term polynomial just called a polynomial, but it has some parts. So let's talk about its parts. First thing up, let's look at specifically, let's look at the 4, the 5, and the -2. Okay, those are what we call coefficients. It is a number, but we don't call it a constant because it's in front of a variable. So it just means that we have 4 of those, or we have 5 of these, or we have -2 of these. It's not a constant number. It will change as x changes. However, as you can probably guess, the 1 is a constant. Now, the number 4 is special. Okay, the number 4 is called the leading coefficient. And college note, and I'm going to let you write it. I'm not going to write them because I didn't write them for those that are in class. So Here you go. Write yourself a college note. 4 is the leading coefficient, not necessarily because it is the first one listed, but because it is the coefficient attached to the variable with the largest exponent. Okay, so that's what makes it a leading coefficient. Go ahead and press pause and write that down. Now, again, let's look at the polygon and look at the exponents now. Turn your attention to the 3, the 2. Remember, there's actually a 1 here, and they are going down the exponents are going down in order. This is called descending order. So if I ask you, have you put your polynomial in descending order, you'll know what I mean. Now let's go ahead and look at the exponents. The largest exponent we have in that polynomial is a 3. That is called the polygon's degree. So this is a degree 3 polygon. Now that's important because, remember earlier I referenced what we called turns. You're going to be able to tell how many turns, or sometimes they're not quite a turn, so we call it a curve, but a polygon's graph could make, we're going to cross off the will and put a could, by taking the degree and subtracting 1. So let's go down here to the bottom and write that out. So we're going to say turns equals degree minus 1. And let's go ahead in front of that, write the word possible. That's the most turns a graph could have. Now, on the other side of that, if you're looking at a graph, the degree of the equation that made the graph will be the number of turns showing plus 1. Okay, now, the degree also tells us how many x-intercepts are possible. Not guaranteed, but possible. So if we slide back up here, this particular graph has a possibility of having 3 x-intercepts. And because its degree is 3, we can take 3 and subtract 1, and it has 2 possible turns. So let's look. Let's go to Desmos real quick, okay? And here we go. Here is, over here, this blue graph right here. Let me make it a little bit, it's already big as it can get. Okay, so you look over here at the top left, 4x cubed plus 5x squared minus 2x plus 1. That's the polygon that we're dealing with. It does have 2 turns. But remember I told you it has 3 possible x-intercepts, but it doesn't have 3. It only has 1. Now, it could very easily have 3 if I come up here and I delete that 1, and let's try to make it maybe like minus 0.5. If I put minus 0.5 instead of plus 1, there you go. It has 3 x-intercepts. Okay, so let's go ahead and delete that, get ready for the next class. Okay, so let me I'm going to pause the notes real quick. I always forget to do this. I'm going to go and put this thing in airplane mode so I don't get any more texts while I'm doing the notes. Okay, all right. Let's go ahead with these. Finish up this first page of the notes. The graphs of polynomials are called continuous graphs. Okay, and what does it mean to be continuous? Let me go back to Desmos. So it means continuous because if you were to put your pencil anywhere on this blue graph and I was to start going up and follow the path, or if I went down and followed it forever, I would never get to a point where the pencil would not be on the graph. So what we are going to be doing is we're going to be getting to some graphs later that actually have what we call a hole. So what does that mean? Well, what that means is that we're going to get to some graphs that if I got, it's going to have what we call a hole. And so if I was to put my pencil, say like right here, and start following this graph, I would get to a point right here where I'm not on the graph anymore. There's a hole there. Okay, so that's one thing that we're headed towards. This is not a continuous graph. This is called a discontinuous graph. And then we will also be getting to some other types of discontinuous graphs. And those will be graphs that have what we call vertical and horizontal asymptotes. And what those graphs look like, it looks something like this, where there is actually two parts to the graph. All right, and again, that's headed, we're going to get to there later, probably I think in Unit 8. Okay, these again are discontinuous because if I put my pencil on this part of the graph, and this goes down forever, I'll never get over here to this part of the graph. So again, those are called discontinuous. All right, last thing on here. Let's cross off this word this, and it's supposed to be the word the. The ending behavior of a graph describes what happens on the left-hand side of the graph and what happens on the right-hand side. So if I look here at the graphs we're going to look at in a minute, the question is, what's going to happen to the graph down here? What happens over here on the left side? What happens over here on the right side? Okay, or something like this. What happens to this graph on the left side? And what happens to this graph on the right side? So that's called ending behavior. Okay, so we're going to go ahead and stop right here. We're not going to go all the way back to the first page, and we're going to talk about what is ending behavior. So we have two types of graphs. We have your graph is either going to go up on both the left and the right. Okay, so let me go on over here and look. Or here's a graph that goes down on both left and the right. Here's a graph that goes up on the left and down on the right. And that's pretty much the only two options I got. They're either both going to go in the same direction or they're not. Okay, over here, these both go up. Okay, over here, I got a down on the left and an up on the right. So how do I know what kind of graph does what? So first up is here, ending behavior if A is greater than 0. Okay, reminder, that means that A is positive. Okay, so if we have an even degree polynomial, then your graph is going to go up on the left and up on the right. Okay, scroll on down here. What about ending behavior if A is less than 0? Again, this is A is negative. If A is negative, we are going to go down on the left and down on the right. Now, what happened to the rest of the graph? Well, if it's an even degree of 2, it's going to look like that, a parabola. But what if it's an even degree 4? Well, then it's going to go up and it's going to come down and it's going to go up again and then it's going to connect. So there is a degree 4. Okay, and then 6 and 8 and 10 have more and more turns. All right, well, how about a odd degree polynomial? Okay, so if we have an odd degree polynomial, then we are going to go down on the left and up on the right as long as A is positive. Okay, and then if A is negative, you guessed it, we are going up on the left and down on the right. All right, and I purposely skipped that algebraic stuff because, man, sometimes kids get confused with that. So I wanted to make sure you completely understood what was going on. So what does this mean? So all this means is, this says right here, as x approaches negative infinity. Let's write that out. Okay, let's write out what this says. As x approaches negative infinity. Okay, that is what this part says. Okay, and this up here says it's a limit. So this we'll talk a little bit more when we get to pre-cal and calculus. I'm more concerned right here. As x approaches negative infinity. So here's the x's. As the x's go to negative infinity, this says, where does the graph go? Remember, f of x is just another way to say the graph. So the graph is going up. Where's it headed? It is headed towards positive infinity. Okay, what about this part? This says, as x approaches positive infinity, well, if we look over here, the graph, sure enough, is headed up towards positive infinity as well. Okay, How about down here? Okay, let's go on back down to our even one. So again, this says if as x approaches negative infinity, so think about that. What that really means is, what does the graph look like on the left-hand side? And the graph is going down towards negative infinity. Over here on the right-hand side, and again, what does this mean? This says as x approaches positive infinity, that's over here. So it's really saying what's going on the right. And where's this graph going on the right? It's going down towards negative infinity. So your even graph, or your even degree polynomials are either both going to go up or both going to go down. Okay, how about over here? Okay, on an odd degree polynomial, if a is positive, okay, again, this is saying what's happening on the left and what's happening on the right. So on the left, we are going to negative infinity. On the right, we are headed towards positive infinity. If a is negative, then again, this is what's happening on the left, what's happening on the right. On the left, we're going towards positive infinity, and on the right, we're going towards negative infinity. Okay, well, that is everything that you need to know about polynomials as far as their graphs go. So now we are going to fill these out. Okay, so that's the next part of our notes. So let's put all that new information to use. All right, first thing, though, I'd like you to write down the names of all of these graphs, and you are responsible to look at a graph and know its shape by name. So this first graph up here is linear, and it is an x to the first power graph. Okay, this is a quadratic graph. You know this already. You've seen them since Algebra 1. It is a x to the second power graph. Okay, this is a cubic graph. This is an x to the 3. Okay, this is called a quartic because it has a degree 4. Okay, this is called a quintic because it has a degree 5. Okay, everybody giggle. And this is called a sextic because it has a degree 6. And this is called a septic because it has degree 7. All right, now let's go up here to this picture and let's go ahead and fill out all the information that we can. Okay, so let's start off with, what is its degree? Well, besides the fact that it has, I told you right up here, it's a degree 1, how do we know? So remember, degree is turns minus 1. So let's go ahead and start there. How many turns does this graph have? This graph has 0 turns. Okay, so if turns is 0, then degree, remember degree is turns plus 1, so this is 0 plus 1, which is degree 1. All right, let's go up here. Now let's do it the opposite way. Okay, so this is degree 2. Okay, how do I know it's degree 2? Well, it has 1 turn, and degree is turns plus 1, so we have degree 2. Okay, let's go over here to the cubic, and then we'll go back and do the x-intercepts and any behavior. Okay, so how many turns does this have? This has 2 turns, and so we're going to put 2 on here. So its degree is 2 plus 1, which is degree 3. All right, now let's go back here and talk about x-intercepts. Okay, how many x-intercepts does this have? This has 1 x-intercept. And because it is a degree 1, it has 1 possible. Now, I notice I said possible because it doesn't have to have 1. You can have horizontal lines that don't have x-intercepts. So it is possible not to have 1. Okay, let's go over here to the quadratic. How many x-intercepts does it have? It has 2 x-intercepts. And because it is degree 2 right there, it also has a possibility of having 2. Okay, let's go over here to the cubic. How many x-intercepts does it have? Oh, this one's a little different. It touches or crosses the x-axis once right there and once right there. So this graph only has 2, but it could possibly have 3 because the degree is 3. All right, let's go back here to ending behavior. Okay, so question is, again, as x approaches negative infinity, here's the x. Where's the graph going? It's going down. So it's going down towards negative infinity. And over there on the right, it's going towards positive infinity. Okay, let's look at this graph. Okay, on the left-hand side, here we go. Where's the graph going? It's going down towards negative infinity. And on the right-hand side, it's going down towards negative infinity. So both of these are going towards negative infinity. All right, and then let's look here at the cubic. Okay, on the left-hand side, here's the left. It's going towards positive infinity. And on the on the right, it's going towards negative infinity. So on the left, it's going towards positive, and on the right, it's going towards negative. All right, let's take care of this one all at one time. Here we go. Degree, well, let's do turns. This one has 1, 2, 3 turns. So degree is 3 plus 1, which is degree 4. This equation has 1, 2, 3, 4 x-intercepts, and because it is a degree 4, it possibly has 4. So it has maxed out its x-intercepts. Okay, here we go. What do we got? We got 1, 2, 3, 4 turns. So 4 plus 1 is a degree 5. This has 1, 2, 3 x-intercepts. So it has a possibility of 5 because the degree is 5. All right, here we go. Degree, what do we got? Well, we got 1, 2, 3, 4, 5 turns. 5 plus 1 is degree 6. So it has 6 possible x-intercepts. Let's see how many it's got. 1, 2, 3, 4, 5, 6. Yep, maxed them out. All right, now let's do all the ending behaviors for this row. Okay, on the left, going up. So as x approaches negative infinity, that's the left, this is going towards positive infinity. On the right, this graph is going up. So as the x's approach positive infinity, this is also going positive. That makes sense because, remember, an even degree has both got to go up or both has to go down. Okay, quintic. Over here on the left, we're going towards negative infinity. And on the right, we're going towards positive infinity. Okay, again, here's the left going towards negative. Here's the right going towards positive. And this one over here on the end, we've got another even degree, so it's got to go in the same direction. And they are both headed towards positive infinity. All right, last one. Here we go. We're going to do this, obviously do this one all at one time. We're going to fill out all the information. So I got 1, 2, 3, 4, 5, 6 turns. 6 plus 1 makes it a degree 7. Okay, x-intercepts. It possibly has 7 of them. Let's see how many it has. 1, 2, 3, 4, 5, 6, 7. Yep, maxed them out. Okay, ending behavior. On the left, it's going down, and on the right, it's going up. On the left, it's going down, and on the right, it's going up. All right, let's go over here. I'm going to do one example with you for the numbered. This is going to be, we're going to do exactly the same thing, except we're not going to have a graph this time. So we are going to just use the equation, and then we've already done some like this, so I'm going to leave those to you, and then I'm going to help you. We are going to cross this off right here, and I'm going to help you doing one of those. All right, here we go. Let's pick 3. Okay, number 1, it's not in descending order, so let's rewrite it in descending order. My largest exponent is a 6. We're going to have 7y to the 6th minus y to the 5th. I have no cube. I have no 4th. Plus 5y squared minus 3y plus 18. Okay, here we go. Letter A, state the degree and the leading coefficient. This has a degree 6. And leading coefficient, the number is 7. Okay, so what does that mean? Well, we have an even degree and a positive leading coefficient. Okay, state how many possible zeros. Okay, zeros is another way to say x-intercepts. Okay, so how many possible x-intercepts? That matches the degree, 6. So let's put out here to the side, matches degree. Okay, letter C. How many turns? State how many turns the graph will make. Okay, and then we need to it's possible turns. Okay, again, turns is degree minus 1. So that would be 5 possible turns. And lastly, use limit notation to describe the ending behavior. So the limit as x approaches negative infinity, the graph, okay, so what are we looking at? First off, it's even, so I'm going to go up, up, or down, down. And because it's positive, we are going up, up. So that's going to go towards positive infinity on the left. And then the limit as x approaches positive infinity, the graph is headed towards positive infinity. All right, let's go do one of these over here. Okay, I'm going to do this middle one right here. Okay, and so remember, all this means, this f of or p of, all it means is substitute this for the x. Okay, just a reminder. So p of 4z is going to be negative 2 times replace x with 4z squared plus 5, replace x with 4z plus 3. So p of 4z equals, let's see, so this is distribute the 2, so it's going to be 16z squared. So this is negative 2 times 16z squared plus, what's that, 5 times 4 is 20z plus 3. So now I need to multiply negative 2 times 16. So p of 4z is negative 32z squared plus 20z plus 3. All right, so I hope you've had a good experience with the notes and that you've got all the information down. If you don't, you can always go back and watch it again. I would suggest you do that. If you were absent Friday, this is what we are working on Monday. Hope you all have a great day, and I'll see you later.